All right, let's jump right in. Today, we're talking about a piece of tech that honestly sounds like it's from a sci-fi movie, but it's real, and it's already here, changing everything. I'm talking about NVIDIA Omniverse, and its goal? It's huge. It's nothing less than simulating reality itself.
So, to really get what Omniverse is all about, let me just ask you this. It's a simple question, but it's a big one. What if we could build the future twice? What if before we built anything in the real world, a car, a factory, even a robot, we could build it, test it, and perfect it first in a completely virtual space?
That's it. That's the whole idea right there. You build it, you test it, you optimize everything in a perfect digital copy, and only then, when it's flawless, do you actually build it in the real world. This whole concept, this is the foundation of something NVIDIA calls physical AI. And what that really means is AI that doesn't just live on a server somewhere. It's AI that can actually understand and interact with the physical world, through robots and other smart systems.
Okay, so how does this all actually work? Well, we're going to break it all down. We'll start with the huge industrial revolution it's kicking off. Then we'll get into what NVIDIA Omniverse actually is and the universal language that makes it all possible, which is called OpenUSD. After that, we'll look at how people build with it, check out some absolutely incredible real-world examples, and then we'll wrap it all up by talking about what this simulated future really means for all of us.
So first things first, we're not just talking about some new app on your computer. No way. We're talking about a massive, fundamental shift. It really feels like we're at the very beginning of a new industrial revolution. And this one's being driven by this incredible mix of AI, huge simulations, and these connected 3D virtual worlds. It's what people are calling the era of industrial digitalization.
And you better believe this has massive economic implications. NVIDIA is positioning this whole thing as the engine for America's reindustrialization. Now just think about it. If you can build these incredibly realistic virtual factories and train up armies of AI robots in a simulation, well, suddenly you can design and build the next generation of manufacturing in ways we never could before. It's a total game changer.
Okay, so that's the big picture, the grand vision. But let's get down to it. What is NVIDIA Omniverse exactly? You hear the name thrown around a lot, so let's nail down a really clear definition.
Yeah, I know, that sounds super technical, right? APIs, SDKs. So let's just break that down. The most important thing to remember is this. Omniverse is not an app. You don't just go buy it off the shelf. It's more like a foundational platform, a toolbox. It gives developers all the basic building blocks, the APIs, the SDKs, the services, so they can build their own amazing applications on top of it. You could almost think of it as the plumbing for this new digital industrial world. It's the stuff behind the scenes that makes everything else work.
Okay, but for any of this to actually work, there's a huge problem you have to solve. How do you get all these different 3D programs and virtual worlds to talk to each other, right? They need a common language, and that language is called OpenUSD. And honestly, this might be the single most important piece of the entire puzzle. This is the best way to think about it. Remember the early internet? It was just chaos, a bunch of disconnected documents, and then along came HTML. It was a standard language, and suddenly anyone could build a web page and link it to any other web page. It created the web as we know it. Well, OpenUSD is trying to do that exact same thing, but for the 3D world. It's the HTML for the metaverse, for digital twins, for everything 3D.
And this really shows you the before and after. Before OpenUSD, it was a total nightmare. You'd build a 3D model in one program, then try to move it to another, and things would break, data would get lost. It was just awful. It was like trying to get a group of people to work together when none of them speak the same language. It's impossible. But with OpenUSD, it's like everyone suddenly speaks fluent English. All these different tools can work together seamlessly in the same virtual space. It just tears down all those walls.
All right, so we've got the platform, Omniverse, and we've got the language it speaks, OpenUSD. So the next logical question is, how do people actually use this stuff to build those incredible simulations? Well, let's take a look at the development platform. Basically, developers have three main ways to jump in. If they want total control, like they want to build something brand new from scratch, they can use the SDKs, the software development kits. Or, let's say they already have their own software, they can use APIs to pull in some of Omniverse's coolest features, like its mind-blowing RTX rendering, and just plug it right into what they already have. And if they just want to get started fast, they can use something called blueprints, which are kind of like pre-built templates for common jobs.
Okay, enough of the theory. We've talked about what it is and how it works. Now for the fun part. Let's see what this stuff can actually do in the real world. And to do that, we need to talk about digital twins.
So first, let's be super clear on what a digital twin is. This is not just a pretty 3D model. Nope, it's a living, breathing virtual replica of something in the real world. It's physically accurate, it runs in real time, and, this is the key, it can be hooked up to the real thing, mirroring its exact condition moment by moment.
So, who's actually using this? Oh, just the biggest names in the business. Take the BMW Group. They are literally building and simulating their entire factories in Omniverse before a single real-world brick is laid. And the implications of that are just enormous. We're talking about de-risking billions of dollars in investment. They can test every single robot's path, every workflow, and find efficiencies that you could never spot on a 2D blueprint. It's all about perfecting the process before you spend a dime on the physical thing.
And when it comes to AI and robotics, simulation is everything. This is a perfect example. Serve Robotics, their little sidewalk delivery bots, they have an insane 99.8% success rate. And you have to ask, how is that even possible? Well, it's because they ran those robots for millions and millions of miles in a virtual world first. They encountered every weird scenario you can imagine, a dog running out, a person stopping suddenly, all in the simulation, before a single robot ever touched a real sidewalk. This is exactly how you build safe and reliable autonomous robots.
And the scale here just keeps getting more and more mind-boggling. We're not just talking about a single product or even a single factory anymore. You've got companies like Cadence and NVIDIA building digital twins of entire AI supercomputers. Let that sink in. They're using this tech to design the next generation of data centers. I mean, think about that feedback loop. They are simulating the very hardware that will power the next wave of AI. It's this incredible cycle that just keeps making everything faster and more efficient.
All right, let's zoom back out. We've seen the platform, we've seen the language that holds it together, and we've seen some just incredible real-world examples. So what's the big takeaway here? What does this all mean for us?
When you boil it all down, the key takeaway is this. Omniverse isn't about escaping into some fantasy virtual world. Not at all. It's about building a powerful two-way bridge between the virtual world and our physical one. It's a bridge that lets ideas, data, and intelligence flow back and forth seamlessly. And that bridge, it lets us tackle problems on a scale we've never been able to before. On one hand, you can simulate and perfect the tiniest little gear inside a robot. On the other hand, you can scale all the way up and simulate the traffic patterns, the power grid, even the emergency services for an entire city. All of it happening in a shared, perfectly accurate virtual world.
And that really brings us to the final big idea. For all of human history, progress has basically been trial and error. You build something, it breaks, you learn, you try again. It's slow, it's expensive, and it's really wasteful. But now we're stepping into an age where we can test a million ideas in a digital world before we commit to just one in the real world. So the question that leaves us with isn't just what can we build, it's if we can solve our problems in a virtual world before they even exist in the real one, what are the truly big challenges we're going to solve next?